Yes, at the moment we've established a pilot plant, what we would call a mini plant, which is basically simulating the entire bioleaching process. We've established that in a laboratory at Sudbury, and that's just undergoing commissioning at the moment. And as I say, the objective of that plant is to simulate what would happen in a much larger process. And we just feed in a few kilograms a day of material into that plant so that we can test parameters and optimize what the process would look like on a full scale. Now, the objective of this pilot plant is not only to treat pyrrhotite material to recover nickel and cobalt, but we're also looking towards producing a bigger variety or portfolio of products. And that includes elemental sulfur and also a form of iron, which we can then send to steel making. And also we will produce a silica type residue, which we can use to make construction materials. But this is a very different approach to treating this pyrrhotite waste. About 20 years ago, we ran a very small pilot plant treating pyrrhotite for nickel cobalt extraction. And technically, the plant worked very well, but the economics of the project didn't stack up because we too were producing a large amount of waste, although it was benign, and basically the costs of that disposal outweighed the benefits we were generating from the nickel cobalt revenue. So now we've taken a completely different approach to the project and said, well, what other products could we make which basically we can create revenue streams from? But more importantly, it basically minimizes the benign type of waste that we would produce. And that's what that's the objective of the current project, is to look at producing more than just a nickel cobalt revenue stream, but basically looking at producing iron, which can go for steel making, and also a sulfur product rather than producing sulfuric acid, which we have to neutralize, and also a silica residue, which we can use geopolymers to make into construction materials.